Alright, trigonometry. So we are going to look at finding trig ratios using right triangles and also use them to find missing angles in right triangles. So this is what we've been talking about in our warm-ups all year. SOHCAHTOA is an acronym, and it stands for sine of an angle. This is the Greek letter theta, and it's just a common variable that's used. So sine of theta is equal to opposite over hypotenuse. So the side that is opposite and the side that is hypotenuse of that given angle. Cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. That's what this SOHCAHTOA stands for. So the toughest thing is deciding which side is opposite and which one is adjacent. So if we're looking from this on this triangle, this is the angle that's marked that we're looking from. So the hypotenuse is easy to identify. So this one would be the hypotenuse because it's the longest and it's across from the right angle. The one that is opposite is the one that is not touching that angle at all. So I kind of like to draw an arrow across from it. So if I was standing here, the one that would be opposite of me would be here. That would be the opposite angle. And the one that's right next door is the adjacent. If you're adjacent to something, you're right next door to it. So this would be the adjacent angle, and this would be the opposite angle, or sorry, side, adjacent side and opposite side. So on here, express each ratio as a fraction, as a decimal, and as a decimal to the nearest hundredth. So sine of L. So first we're looking from angle L. So opposite of L, because this is opposite over hypotenuse. So this would be the hypotenuse, and this would be the one that's opposite. So I would say 12 over 37. And to the nearest hundredth, 12 divided by 37 is 0.32. Okay, so cosine of L. Cosine is adjacent over hypotenuse. So notice the hypotenuse does not change, but now the one that's adjacent is here. It's the one that's next to it, so that's 35 over 37. Which is 0.95. And then tangent is opposite over adjacent. So opposite was the 12, adjacent was the 35. Which would be 34 hundredths. Okay, now if we are going to look from angle N, I'm going to erase this on here and say my hypotenuse does not change, but now this is the angle I'm looking from. So now my adjacent and my opposite are going to change. So now the one that is opposite of this angle is over here, and that's the one that's going to be in the numerator. So opposite over hypotenuse is going to be 35 over 37, which if you notice is the same thing as what was over here, so 0.95 or 95 hundredths. Cosine then is adjacent over hypotenuse, so this one is adjacent, the 12. So 12 over 37, which would be 32 hundredths. And now the tangent is opposite over adjacent, so that is going to be 35 over 12, which is 2.92. Okay. Now we are going to use those to solve for a side. So fitness trainer sets the incline on a treadmill to 7 degrees. The walking surface is 5 feet long, so we have a diagram that goes with this here. Approximately how many inches did the trainer raise the end of the treadmill from the floor? So y is what we're trying to find. So on this triangle, here's my angle. I'm going to decide from that angle, do I have the opposite, the adjacent, the hypotenuse? Which of those do I have? So on here, we have the hypotenuse. So here's my acronym, my SOHCAHTOA. So right here, I want to now say how is y related to this angle. So is that across from the angle, is it opposite, or is it right next to it, which would be adjacent? So this is across from the angle, so that is opposite. So which one over here uses opposite and hypotenuse? So you look in here, which one has opposite and hypotenuse? Right here. So that means I'm using the sine function. So I'm going to say sine of 7 equals opposite over hypotenuse, so that would be y over 5. So then on here, if I want to get y by itself, I multiply both sides by 5. 5 times the sine of 7 is what's going to get typed into the calculator, just like this. And that gives me does it say what to round it to? So let's just go to the nearest hundredth again, that would be 0.61. So a little over a half of an inch. Okay. When you are trying to find an angle, we're going to use what is called the inverse on here. And you can see on the calculator, these right here are our inverse buttons. When you see that little power, -1 power, that means inverse. It's just a math way of saying that. So angle P over here, I'm going to mark that angle. And I'm going to say which sides do I have on here. I have the hypotenuse again. And then is this adjacent or opposite? So across from it would be opposite. So this would be opposite over here. So the one I have is adjacent. So adjacent and hypotenuse uses cosine. That's adjacent and hypotenuse. So I'm going to set this up the same way. I'm going to say cosine of P, because it's always sine or cosine of the angle, is equal to adjacent was the 13, hypotenuse was the 19. So if I want to find the angle, I'm using that inverse. And then that gets typed into the calculator. So just like this. So I have to use the second button to get the inverse cosine of 13 divided by 19. And it says to the nearest tenth, so 46.8 degrees. Alright, and one more. So it says on the last example to solve the triangle from example 3. So solve the triangle means find all 3 sides and all 3 angles. So we already have quite a bit on here. We have QP is 19. We have RP is 13. We need to find QR. We have angle R is 90. That was given to us. Angle P we just found, which was, this says to the nearest degree, so we're going to call that 47. And we need angle Q. So these, in this case, are not that bad to find. If I'm going to find angle Q, I can just do 180 minus 90 minus 47, which is going to give me 43 degrees, so we found that one. And then if I need to find QR, I can just do the Pythagorean theorem. So I could say 13 squared plus x squared equals 19 squared. And then I would subtract from both sides and get x squared is 192, which gives me an x value to the nearest hundredth of 13.86, which is what QR would be. So once you have all 6 pieces of the triangle, then you have accurately solved that triangle. Okay, so you have 2 to try, 1 to find the side length, 1 to find the missing angle. And your joke of the day, why do shoemakers go to heaven? It's because they have good souls. Okay, I hope you have a lovely rest of your day, and make sure you're kind to someone today.